Today, we're going to spend another day on finding the area between two curves with some problems that are a little bit more complicated. Okay, so we have this shaded region bounded by the functions f of x equals the 3x cubed minus x squared minus 10x plus 1. And that's a cubic. So, and I'm pointing to this one, right? This one's f of x. So it's curving like this one, all right? And then right in this region, if you look, f of x is the top function. And then you look at switches after this intersection point right here, and it becomes the bottom function. And then we have g of x, which is negative x squared plus 2x minus 1. So that's the upside down parabola. Okay. And so right in this region, it's below. So that's going to be our bottom curve. And then it switches and now it becomes the top. So we're going to have to write two integrals in order to find the shaded region. Okay. So the very first thing we want to do is we want to find the intersection, and we're going to use technology, a graphing calculator, to figure this out. Okay. So we want to know what are the coordinates of this point right here, this intersection point, this intersection point, this intersection, and this intersection point. All right, so to do that, you have to write the equation that you're solving. So we're going to solve 3x cubed minus x squared minus 10x plus 1 equals, and then negative x squared plus 2x minus 1. And we're going to let f of x equal y1, and I'm going to let g of x, you don't have to write this, equal y2. This is there just to help me remember which one's which. Okay, so I'm going to store in my calculator y1 f of x and y2 for g of x, and I'll do that, and we'll go to the graphing calculator now. Pressing y1, and for y1 we're going to again enter the function f of x. So that was 3x raised to the third. And then remember to come down out of the exponent. Whoops, I came a little too far. There we go. And then minus x squared and minus 10x. And then plus 1. And then y2, just double check to make sure 3x cubed minus x squared minus 10x and then plus 1. Okay, just double checking, right? And then negative x squared and then plus 2x and then minus 1. All right, so to set my window, what I would do is go and looking at, if they give you a graph, look at the graph. Okay, so the left side, the x-min is negative 3. So I'm going to type that in. I mean, you can use it to your advantage, all right? And the x max is 3, and I would do the x scale by 1. They did 0.5, okay, so we'll keep it at 0.5. And then y min is negative 12. And y max is 8. And the y scale, they went by ones. I know they're only marking every 2, but they went by ones. And then let's press graph and let's see what we got. So there we go. All right. So we want to find this intersection right here. All right. We're going to call this one A. We want to find the x coordinate of this intersection and also this intersection. Okay. So we're going to press second calc and select number 5 for intersect and move over to the first curve. And we're going to press enter for the first curve and enter for the second curve. The guess is just going to, you want it to be as close to the one you're trying to find as possible, because then it will find that one, okay? And it'll do it quickly too. Okay, so it's negative 2.0786, so the 6 is going to make the 8 become a 9, so negative 2.079. I'm going to go back to my home screen. I'm going to take that x and I'm going to store it as alpha A. And now I can use A instead of having to use negative 2 type all of this, right? It allows me to use all of the decimal places that I have here, okay? So then go back and we're going to press second, trace again, and select number 5 for intersect. This time we're going to get that second intersection point, so I'm just going to get close to that one. And then press enter, enter,
and then the guess is just next to it. Okay, and then this 0.1678, so that's 0.168. And again, go to the home screen. We're going to take that x and we're going to store it as alpha b. And then again, second calc, or you can go to the graph and then go to calc 2. Coming over here to the third intersection point, and first curve, enter, 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 and 1.9107. So this fourth decimal of 7 is going to make that 0 become a 1. So 1.911. Okay, so then second quit, and we're going to take that x and store it as alpha c. Okay. All right, so there we have our values, right? And they're stored. So now let's go back to the problem and write them down.
So when we put this into our calculator, we got x is about negative 2.079. And then I'm going to write 3 dots. And I stored that one as A, like you saw in the calculator. Okay, and the second answer is 0.168. ... And that's going to be my B, or was my B. And then the next one is 0.11, sorry, not 0, 1.911. And that is my C that I stored in the calculator. All right. So what we're going to do to set this integral up, we're going to integrate. Okay. And you could even write this: let A equal negative 2.079, B equals 0.168, ... and C is equal to 1.911. And instead of having to write the numbers, now that you said what A is and B is and C, you can use that. Okay. So we want to go right here from this value to this value. Okay. So that's going to be from A to B. And we are going to integrate f of x minus g of x. Dx. And that takes care of this first shaded region. Now for the second region, we're going to add to that the integral from B to C. And in this case, it's going to be g of x minus f of x. Dx. And that's one of the reasons I wrote this up here, is to keep track of what's what. So this is going to be y1, and this is going to be y2, and then this is y2 minus y1. Okay, so we're going to go back to our calculator. Okay, and we could even write area here is equal to this, and then you can just put this into your calculator and get an answer. Okay, and I don't mind if you write f of x minus g of x, because whoever's reading this knows by definition f of x is this. So you don't have to actually write the function, the actual expression for the function. Okay, so let's go to the graphing calculator and let's put this one in.
So we're going to integrate now. So we're going to press alpha window and select number 4 for function integrate. And we want to integrate from A to B. So alpha A to alpha B. And then the top curve for that from A to B, from that first intersection to the second intersection going from left to right, f of x is the top curve, and we had that stored as y1. So we're going to go alpha trace and select number 1, and then minus alpha trace number 2 for y2, and then dx. And then we're going to add to that the integral again. So this alpha window and function integrate. And this time we're going to go from B to C. So alpha B to alpha C. Now remember, okay, it's not y1 minus y2 anymore, right? Because now g of x on that second region, the g of x is the top function. So that would be y2. So alpha trace y2 minus alpha trace y1, and then dx. Hit that enter button, and we get 24.5017. So this 7 right here is going to make the 1 become a 2. So we should write 24.502, but it's acceptable also to write 24.501, okay? So the area, that combined area of those two regions was this number right here, 24.502.
So from the graphing calculator, we got 24.502. Okay, and once again, okay, so this right here, that's representation of one rectangle, right? It's one rectangle right here. And that's why it's f of x minus g of x. And this is another one right here. And we're creating these rectangles starting here and going all the way across to here, and then from here to here. Okay, and that's what this area represents. For this next example, we have a line g of x, and that's the 1.5x plus 4, and the parabola, which is f of x, negative 1.5 x squared plus 7. And I want to find this shaded region. Now, this is bounded by the y-axis and the x-axis. So if you look at this, if I draw my rectangles, right, this is going to be one of them right here. Okay. We're going to start making them right here at 0, and we're going to go all the way across to this x-intercept right here, okay? And that's where we stop making them. And then it's going to be really close to 1. And then after that, we have a different rectangle because the top function is something different. It's this one right here. And we're going to have to integrate from this intersection point to this x-intercept. So there's actually two things we need to solve for. We need to solve for this, and we need to solve for this when it's 0, okay? So the way we can do this one is the x-axis, all the coordinates, all the points on the x-axis have a y-coordinate of 0, so we can say y equals 0 is the same as the x-axis, all right? So there's actually two things we need to solve for this, okay? This intersection, which we'll do with the graphing calculator, and this x-intercept right here, okay? So the two equations we need to solve are negative 1.5 x squared plus 7 is equal to the 1.5x plus 4. And then we also need to solve for this parabola f of x is equal to 0. So negative 1.5 x squared plus 7 equals 0. So I'm going to let y1 equal f of x. And I'm going to let y2 equal g of x. And y3 is going to equal 0. Okay, so let's go to our calculator, put that in, and solve these two equations.
For this next equation, we're going to type in y1 is that negative 1.5 x squared plus 7. So I've already cleared out the y entries, okay? So I'm going to type in negative 1.5. If you didn't, you just need to delete those, okay? So negative 1.5 x squared plus 7. And then y2 is going to be the g of x function, which is 1.5x plus 4. And then y3 is going to be y equals 0. And remember that y equals 0 is the x-axis, okay? And then we're going to use the grid again to help us. So x-min this time I would set as negative 1. The x-max at 3 is good. Scaling by 0.5 is good. Y-min, negative 1 it looks like. And Y-max is 8 again, looks like. And we can scale by 1s again. And if we graph, we see what we need to, right? So we're talking about this region right in here, okay? And again, this line is the top curve. The bottom is really y equals 0, right? So we would subtract 0, but we really don't need that, right? Because we've already learned how to do it to the x-axis. It's just the function, right? The height of the function is the same as the height of the rectangle. Now right here, this intersection point right here that I'm pointing at, okay, we got to find that because all of a sudden from this region over, right, now this is the top curve, and then we also need to find this intersection point, okay? This might be a nice number, it might not be, I don't know yet, okay? I know because this is a line, and the y-intercept of our line is 4, so I know this is 4 right here, but let's find this point right here. So again, we're going to press second, calc, and select number 5, intersect, and boy, right there, huh? Enter, enter, enter. Okay, and it's actually a nice value, right? When x equals 1, y is 5.5. So because that's an exact value, we don't really need to store it. You can, but you really don't need to, because we could just type 1 very easily. I mean, that's actually typing 1 is going to be easier than typing a letter. Okay, so now we know that that's 1. All right, so we can go back to our paper and we can write that. And then we'll do the next one. We'll find this value right here. And then to find this x-intercept, we're going to move really close to over there. Let's press second. Intersect first, right? 5 intersect. Okay, select number 5 and then come down. And okay, so we got to be careful because there's 3 curves. Okay, so the first curve, yes. And you look at the color. Okay, this is nice. When these were black and whites, this was hard. It was harder. The blue one, yeah, I want the blue one, right? I want to find the intersection of the blue and the green, right? That's why it's nice to have different colors for each one too. Okay, so we're going to press enter. Okay, I don't want this red one, right? So I'm going to scroll down and pick the green one. And when this switches to green, okay, yeah, those are the 2 I want, right? I don't, because what that would do is find this one again, all right? And then the guess, we just need to be near. And this is not a nice clean number, right? So 2.1602, the 2 is going to keep that 0 staying as 0. So 2.160. Now, since this is the end, and I'm thinking like A to B and B to C, I'm going to call this C right here. So I'm going to take this X value and store it as C. You don't have to, okay? There's nothing that says you have to store it as C. Yet you just have to store it as something, okay? So alpha C. Now that last problem, okay, I've overridden what the C was before on that last problem, and now it's this one, okay? All right. So let's go back to our paper now.
So from our graphing calculator, we got this one to be, it turns out to be exactly 1, okay? And then this one turns out to be x is about, and we got 2.160 ... So because this is the third one, we're going to start from here to here to here. I'm going to call this one C. So I'm going to let C equal 2.160. And that way I can just write C instead of the 2.160. So to find the area of this one, okay, we have to start by starting to get the rectangles, start creating the rectangles at x equals 0 to right here, this x-intercept, which is 1. And the top curve is g of x, right? And so we can write just g of x. And the bottom curve is this y equals 0. Well, if we subtract the 0, we really don't need that. So we can just write dx, okay? And that would give you this shaded region right in here. Now we need to go from 1 to this value right here, this x-intercept. So we need to add to that the integral starting at 1. And we can either write c or you can write 2.160. I'm going to write c because I've said I know what c is. It's the same as 2.160. And then what is this function? This one's f of x, right? So then f of x dx. Okay, and so we're going to go and put that into our calculator and we'll have it.
So now we want to do the function integrate, right? So alpha, window, and select number 4. And because it's starting on, we want to start creating these rectangles on the y-axis. We want our lower limit to be 0. And then we want to stop it at that intersection of 1. Okay. And then it was g of x, right? And so g of x is the top curve here. It's that line, right? So just going back, I'm going to go back and look at the graph, okay, and trace. And it's the line, right? We want this line, right? That's the top curve. So, okay, so I need to put in for y2, okay? And I'm going to integrate y2. So alpha trace 2, and then dx. And then we need to integrate from 1 to that c value, right? So plus, and then again, alpha window, number 4, function integrate, and we're going to go from 1 to that stored value, right, which was alpha c, And this one was f of x, and we stored f of x as y1. So alpha trace y1. And then dx. And this will give us the area of that region. So 8.331 is the area of that region.
And so from our graphing calculator, we get 8.331. And the only requirements are you write the equation that you're going to solve, you solve it, right, with the graphing calculator, and you write the equation you're solving, and you solve it, and then you write your integral. And you can use g of x. You could also write 1.5x plus 4. Those are interchangeable because they're the same. Same thing with c. C is 2.160. You can either write c or you can write 2.160. The big thing, though, is if you write the number, you don't want to use only the 3 digits, okay? Or the hundredth place, right? You want to use the full thing. So even if you write 2.160, you don't want to use it. You want to use the entire value of this x-intercept, okay? For this next problem, all we're going to do is we're going to write the integral, okay? And we're going to write it in terms of x and also in terms of y. So we're going to do this problem 2 different ways. So we have f of x is equal to 2 times the natural log of x. That's this one right here. Okay, I'm going to write this one as y is equal to 2 ln of x. And then this one right here is y equals 2/3 x minus 2. And the first time out, we're going to draw our rectangles this way, so that would be in terms of x if we draw our rectangles this way, because our thickness is going to be dx, or our width is going to be dx. Okay, so to find in terms of x, all right, we're going to have to solve this equation, right? 2 ln of x is equal to 2/3 x minus 2. Okay, now we're gonna want to solve this for the x coordinate and the y coordinate. So I'm gonna call this point right here A comma C, and I'm gonna call this point right here B comma D. All right. So then when I find the coordinates, I'm gonna save the x coordinate as A, and I'm gonna save the y coordinate as C. This one, I'm going to save the x coordinate as B and the y coordinate as D, because we're going to want to integrate this way, and I'm going to need the y values. So that's why I want to store the x and the y on this. Okay. So I'm going to go put that in the graphing calculator, and I'm going to store all these as A, C, B, D. Okay. And then we're going to write the answers to this like this. Okay. All right. So here we go.
All right, so we want to clear our home screen off, and y equals, we want to clear all these entries out. And come back up to y1. And we're going to type in y1. I'm going to let that be 2 ln of x. So 2 ln x. And our y2 is going to be the 2/3 x minus 2. So I'm going to get a fraction bar here for my slope. 2/3 x and then minus 2. That's my g of x, right? All right, and again, I'm going to go to my window, and we're going to graph this from -1 to 10. So my x min is good at -1, x max at 10. X scale is by ones. If you left it as 0.5, it wouldn't be bad. And then y min is -3. And y max at 6. And y scale looks like the tick marks are every 1. So we'll keep it like that. We'll graph this and take a look. This is the blue one's the natural log function, and the red one's the line. And we got to find this intersection. Now, again, I'm going to store the x value right here as A, and the y value as C. And over here, this intersection, I'm going to store the x value as B and the y coordinate as D. Do you have to label them that way? No. Okay. It's just the way I chose to do it. All right. So press second, calc, and number 5, intersect. Come back over here. Okay, and then just press enter. Enter for the second curve, guess, and there we have it, right? So we want to store this x value and this y value because we're going to do 2 integrals, right? We're going to do in terms of x and also in terms of y. So that's why I wanted to store the x and the y. Okay, and one thing to point out, okay, so they kind of place y kind of in a nice place. It's right here with number 1, all right? So we go to our home screen and we take that x and we're going to store it as alpha a. And now a is that number. And then to store y, we have to press alpha and then select number 1 for y and store that one as alpha c. And so if I want to use that x coordinate or the y coordinate, if I want to use the x coordinate, I'm going to type A. If I want to use the y coordinate, I'm going to type C. And now we go back and we find the second intersection point. Okay, so number 5. And then we're going to come all the way over here and press enter, and then enter for the second curve, and then guess, it'll give us that one. So again, I want to store this one as the x and this one as the y. So second quit, I'm going to take the x and store it as alpha a, as alpha b. Okay, that would have been bad, okay, because then I would have had to gone back and find this a one again, right? Because it would have overridden it, okay? And then we want to take the y, so alpha, number 1 for the y, and then store that one as alpha d. Okay? And then we can go back and we can record these values.
So when we solve this on the graphing calculator, we got 0.424. And we also got 9.868. Okay, so we're going to let my A be this x, which is 0.424 ... And we're going to let B equal this one, 9.868. Okay, so then if we want to find this area, this region in terms of x, okay, what we're going to do is we're going to integrate, all right, and we're going to go from A to B. And the top curve, okay, is the 2 ln of x, or f of x, and then minus the bottom curve, which is g of x. Okay, so then, and then dx, and that would be our answer. Or we could also write it like this. Okay, so my f of x was the 2 ln of x. So on Delta Math, we're gonna have to write it this way. I just realized, wait, we're putting these into Delta Math, so sorry about that. Okay, so for a right here, we're gonna need to type this into Delta Math as 0.424 to 9.868. And then this would be the top curve, which is 2 ln of x, minus, and then this one, because it's a difference, we're going to need parentheses around it. So 2/3 x minus 2. You don't have to simplify this unless it says to, but that would be that. These are equivalent, okay? On the AP exam, you could write this if you're using technology, okay? All right, so now in terms of y. Now in terms of y, all right, I stored this y coordinate as c and this coordinate as d, as you saw in the calculator, okay? But what I'm gonna do is I need to switch these to y equals equations, okay? So I have, in terms of y, I'm gonna switch colors here because this is gonna be like almost an entire different problem, okay? So in terms of y, we're gonna let C equal, and I have it in my calculator, okay? So C is negative 1.718. And my D, dot, 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 and my D, is 4.579. Now, we have y is equal to 2 ln of x. What I need is an equation with x. So in terms of x, okay, what I need to do is divide both sides by 2. So I get y over 2 is equal to ln of x. And then I'm going to exponentiate both sides. So we get e to the y over 2 is equal to e to the ln of x. And so we have e to the y over 2 is equal to x. So this one right here, this curve right here, okay, can be written in terms of x. It would be x is equal to e to the y over 2 power. That's this one right here. Okay, so what's this one in terms of x? So this one was y equals 2/3 x minus 2. What I'm going to do to get rid of this fraction right here, I'm going to multiply both sides by 3. So this becomes 3y equals, I'm going to distribute the 3, so that's going to make 2x minus 6, and then I'm going to add 6, so that'd be 3y plus 6 is equal to 2x, and then that would make 3y plus 6 over 2 equal to x. So that means this equation right here could be written as 3y plus 6 over 2, and that's equal to x. Or you could also write this as 3/2 y plus 3 is equal to x. You could write it that way too, okay? Either way is fine, all right? So now in terms of y, that means we're gonna write this as, okay, we're gonna start making these, and we're gonna go this way. We're gonna go sideways this way time, right? We're gonna go, our rectangles are gonna be horizontal. So this is gonna be dy. That's why I had to get these into terms of x, okay, or x equals equations. And so we want to do the right one, which is this line minus this, right? So this is e to the y over 2, and this is the 3/2 y plus 3. And I'm going to integrate this from this y value. I'm going to start creating them right here, and I'm going to draw them until the top y value of d. So that's going to be negative 1.718 to 4.579. And we're going to go right minus left. So in this case, it's 3/2 y plus 3 minus, and since this is just one term, we can write minus e to the y over 2. And then dy. So whether we do this one or this one, if we integrate them, they would both give us the same value. Okay? Now, I'm not asking you to actually integrate them. I just want you to set them up. Okay? So that's it. Just set them up. All right. So for this next one, okay, this top horizontal line, this is the region R, the shaded region is R. It's bounded by x to the 1/3 plus 1. Okay, so that's this curve right here. So that is y equals x to the 1/3 plus 1. I'm using y because, and I did on the last one too, because I know I'm going to want to switch these to x equals equations, okay? Horizontal line y equals 3. That's this one. The y-axis, now the y-axis right here is x equals 0. Okay, and then we want, again, write an integral in terms of x and y that would represent the area of the region R. Okay, so we want this region R, right? So the very first one is we're going to do in terms of x. Okay, so we're going to start making these at 0, and we're going to end it right here at this x-intercept right here. So I need to figure out what this x-intercept is. So I need to solve the system of equations. You know, x to the 1/3 plus 1 is equal to 3. Okay, so we have x to the 1/3 plus 1 is equal to 3. And I'm going to let, y1 be this x to the 1/3. And I'm going to let y2 equal 3. All right. And so we're going to go and we're going to solve this. So we'll go to our graphing calculator and we'll solve this on the graphing calculator. And we're going to store, I'm going to store this one as, let's call this point a comma b. And so I'm going to store this x coordinate as a. Okay.
So again, I'm going to clear my screen out, and y equals, clear the y1 entry and the y2 entry, and then come back. And I'm going to let y1 be the f of x, so that'd be x raised to the 1/3 power. You can do 1 divided by 3, or you could use a fraction bar, either way. But make sure you come out of the exponent, okay? I have a tendency to forget to do that, so just make sure you're doing that, okay? And then y equals 3 for y2. And that's it. Okay, so let's go to our window. I would go like something, looking at the grid, -2 to 9, and scale by ones, and y min at -1, and y max at 4, and y scale by 1. And let's graph and take a look at this. Okay, so we want to find this intersection point right here, right? And we want to get the x and the y coordinates, okay? So again, we're going to press second calc for number 5, intersect, and enter, and enter. And the guess, we just got to be closer to that one, right? This is the only one right here. And it turns out to be, this is a nice value, 8.3, right? So I wouldn't store this because it's just easier to type 8 or 3, whichever one we need. All right.
We solved this with the graphing calculator, and we got x was not approximately, but actually exactly 8. Okay. So you know what? I take that back. I don't want to store that. Since they're exact numbers, we can just use those exact numbers. So I'm going to cross this out. And instead, I'm going to go from, that's the point 8,3. Okay. So again, in terms, you got to write this. Okay. But I would write x equals 8 because it came out to be exact, right? Doesn't always, obviously it doesn't always come out to be exact, right? We got lucky. We got a problem that did that. Okay. Inexact. All right. Not an exact, in terms, that's what I meant to write, in terms of x, right? To find this, this is the top curve and this is the bottom curve. And so we're going to subtract those to get this height. Now, again, our width of our rectangles are going to be dx. And we're going to do this. We're going to start making these rectangles right here, and we're going to stop them right here at this point at 8. So we're going to start at 0 and we're going to end it at 8. So the area could be calculated by taking the integral from 0 to 8. And the top curve is 3. So I'm going to write 3 and then minus this curve, right? Now, this curve is a sum, so I have to put it in parentheses. So minus x to the 1/3 plus 1, close the parenthesis, close the bracket, and then dx. Okay? So then let's go do this in terms of y. So now we're going to start, all right, right here. And I know you can't see it because there's not much area right there, but we're actually going to start rectangles right here, and we're going to go horizontal. So I'm going to draw just this one right here. Okay. And so we have to get the length of this one here. Okay. Now, what's great is that's the y-axis, right? So all we're going to do is it's this function. Okay, it's going to be this is going to be the right, and this would be x equals 0 right here because that's the y-axis. On the y-axis, all the x coordinates are 0. So the equation for the y-axis is x equals 0. So we're going to start by, we should realize that the x-intercept or the y-intercept for this one is 1. So this point we automatically just by inspection is, this is 0, 1. Okay. All right, so then we're going to start making these at this y value of 1, and we're going to make them all the way to 3, okay? Now, again, to do this, we got to switch this, and we got to make this an x equals equation, right? So it's y is equal to x to the 1/3 plus 1. I'm going to subtract the 1, and we get y minus 1 is equal to x to the 1/3 power. And then we need to raise this to the third power, because if I raise this to the third power, that's going to force me to multiply the exponents, and 3 times 1/3 will give me 1, which is just x. So this is going to be y minus 1 to the third power is equal to x to the 1/3 power raised to the 3. So this left side becomes y minus 1 to the third is equal to x. So now this curve right here, the same curve that was y is equal to x to the 1/3 plus 1, becomes x is equal to y minus 1 to the third power. All right. So in terms of y, all right, what we're going to do is to find this area, that's going to be equal to the integral, and we're going to go from 1 to 3. And then it's going to be right minus left, but this, it's really just y minus 1 to the third minus 0, because it's going all the way to the axis, right? So really, this would just be y minus 1 cubed dy. And that would be the area in terms of y, whatever we got for that, okay? So again, in Delta Math, I'm having you set these up, but I'm not having you actually calculate them, okay? All right? And that's it for today.